Acid rock drainage is a potentially dangerous byproduct from mining operations. It is created when mining fluids remove sulfate from geological sources such as pyrite. The sulfate turns into sulfuric acid in solution and increases the acidity of liquid mining waste. The low pH allows the liquid waste to dissolve heavy metals such as iron, manganese, zinc, and copper. The presence of dissolved iron tends to give acid rock drainage its yellow color. Currently, most mines remove the acid rock drainage and transport to hazardous waste management facilities. If disposed of improperly, the acid rock drainage could leach into groundwater or run off into surface water. Because our drinking water is extracted from these sources, acid rock drainage can adversely affect human health, not to mention the environmental impacts associated with the runoff.
The purpose of this video is to provide a laboratory skill test of one way to mitigate acid rock drainage impacts on the environment and humans through treatment. By providing a method for mines to treat the acid rock drainage at the site, we can eliminate the need for transporting the waste as well as reducing exposure of the hazards. By raising the pH or reducing the acidity of the acid rock drainage, it is possible to precipitate the heavy metals from solution. The precipitates that float on the surface can be skimmed, and the precipitates that sink to the bottom can be removed by raking. In this experiment, we will be using copper dissolved in acetic acid to mimic acid rock drainage. We will be adding a solution of sodium hydroxide, a strong alkaline, to increase the pH and precipitate the metals out. We hope to show the precipitation of metals is a viable, large-scale method of removing heavy metals from acid rock drainage, while also neutralizing the pH to allow for safe discharge. In doing so, the environmental and human impacts can be mitigated.
The experiment we're about to show explains how we get copper hydroxide from copper acetate and sodium hydroxide. The copper acetate was formed by dissolving pennies into acetic solution, which created copper acetate. We will combine that with sodium hydroxide to form copper hydroxide. The jar on the left is filled with acetic acid, in which copper from 5 pennies has been dissolved. The acetic acid was obtained from household vinegar, which contains about 5% acetic acid. The solution is blue due to the copper oxidizing once in solution. The jar on the right contains sodium hydroxide and water. The sodium hydroxide was obtained from household lye, which is 100% sodium hydroxide. We will be adding the sodium hydroxide solution to the acetic acid. As you can see, the precipitate begins to form almost immediately. It is also an exothermic reaction, as you can see from the bubbles. Now we will shake the container to see how the solution responds. The precipitate has now reached the entirety of the solution. This precipitate is called copper hydroxide, which was discussed earlier.
It's obvious that precipitating metals out of an acidic solution is possible, but scaling to treating acid rock drainage presents some challenges. We showed our experiment as a batch reactor, but in practice, this would be efficiently done as a continuously mixed flow reactor. In addition, the base used to increase the pH should be non-reactive, which may be difficult with unknown species in solution. Through our experiment, it was shown that the addition of an alkaline solution was a viable treatment process for mitigating acid rock drainage, proven through the solid precipitate that was formed at the bottom. Thank you for watching.